This is Honors Algebra 2 Pre-Calc. We're doing another video on absolute value equations. We're going to do an E4 and P4 that involve a trick question, and we're going to show what happens if you spot the trick, which is great, and we're going to show what happens if you don't spot the trick, which is also okay, but if you don't spot it, you're going to have to do a little bit more heavy lifting to make sure that you don't accidentally put the wrong answer. Okay, so we're going to solve these the same way that we've been solving. So let's start with, I'm going to start with E4, and then we'll talk about P4 after. Okay, so I'm going to start with SADMAP. I'm going to subtract the 7, right? So I'm going to get negative 2 times this absolute value of x minus 3 equals a 4. Start with my subtraction and addition, right? I'm going to do my division and multiplication. When I do that, I divide by negative 2. And I'm going to get that the absolute value of x minus 3 is a negative 2. And right at this moment, I can spot that there is no solution. Okay, so no, S-O-L-N, no solution. It's not cheating if you can spot that at this moment. But what I ask of you if you spot it is that you communicate to me why, so that I understand that you made the mental leap that was correct. Because sometimes the answer is that something doesn't have a solution, but your logic for why might be incorrect. It doesn't matter to me so much that you show a ton of work, but if you make a mental leap, I need you to articulate what that leap is. In this case, I know that the output of that absolute value is non-negative, right? Essentially, I know that this left-hand side, this left-hand side is just an absolute value, has to be greater than or equal to 0. And I see that the right-hand side is very much a negative number. So that's not possible. I can't have a left-hand side that is greater than or equal to 0, right? So another way to think about it is that the left-hand side is either positive or 0, because that's the output of an absolute value is positive or 0. If the left-hand side is positive or 0 and the right-hand side is a negative 2, that's just not physically possible. So if you see that the answer is no solution and you can articulate that, that's dope and awesome. Here's the problem if you don't see it. If you don't see it, so if you miss that mental leap, and you're gonna miss the mental leap sometimes. So just a spoiler alert about life in general. Some days we catch tricks and some days we don't. So I can do the same problem dozens and dozens and dozens of times. It's happened with AP Calc questions. There are some that I have done literally maybe over hundreds of times, like tons of times. And some days I just don't see a trick that I saw 30 other times or 40 other times, and I just don't see a trick. So some days you're going to spot why this is true, and you'll be like, that's awesome, I get it. Cool, I articulated it, I get my points, I got my answer. Other days you just won't see something, and that's not a big deal, and you can't beat yourself up over it. But if you miss the mental leap, let's see what would have happened. Your positive case, so this is the first hint that something's wrong. What do you notice about your quote-unquote positive case? X minus 3 is a negative 2. Oh, that's weird, right? Like that, I want that to be weird in your brain, because you're thinking, hey, that's the positive case. If you tried to solve, you'd add this over and you'd get x is 1. Cool. If you tried to do your negative case, you'd get x minus 3 is an opposite of negative 2, which is a regular 2. So you'd get x equals 5. So if you missed it, you'd get these answers, question mark. Well, they're not answers, because if you go back and check the original statement, if you check them, they're not going to work. So it might seem like you got an answer, but if you check them, you're going to get negative 2, absolute value of 1 minus 3, which is the absolute value of negative 2, plus a 7, should give you 11, right? Well, this is a negative 2 times a regular 2 plus 7, right? That's a negative 4 plus 7, which is definitely a 3, not an 11, right? So this is not a solution. It doesn't work, even though mathematically it felt like it should, it doesn't, right? And the same thing's going to happen if you check this 5. You're going to end up, so also, like when you plug in that 5, you're going to get 3 is not equal to 11. This side's going to be a 3, that side's an 11. So the trick is that if you miss the mental leap, you might come up with 2 answers, and they might be wrong, because if you had actually plugged them into check, they don't mathematically work. So if you're ever not sure, it's not a bad idea to check your work. I never make you check your work. But if you're not sure, you can check every single answer. I don't think that's the best use of your time. And sometimes the very worst case scenario is that you miss a mental leap and you miss some points on a question, and it's not the end of the world, right? It's not the end of the world on an AP. It's not the end of the world on one of my tests. It's not the end of the world, period, unless it was like some equation that was saving humanity from like a terrifying giant asteroid, and then, well, I guess we're all dead anyway. It's fine. So point being, sometimes you're going to see the trick, sometimes you're not. Either way you go, the answer would end up being no solution. There is no answer, but again, you either see it or you don't. So if you want to walk through P4, it's going to be the same trick. I'm going to walk through it right now. And again, you would be able to get two answers that wouldn't work if you didn't spot the trick, right? But I'm going to walk through P4, and then after we walk through P4, we're going to talk about how to put things on a calculator. And we can actually put these on a calculator, and you can see why there's no solution if you want. There's another way to visually confirm there's no solution. So we'll put that on a calculator, and I'll show you. If I were to solve this, right, I would subtract the 8 first, and I would get 3, absolute value of 2x plus 1 equals negative 6. I divide everybody by 3, and I get the absolute value of this 2x plus 1 is a negative 2. And right there, that's where I say, oh, wait a second, this side is positive or 0, because that's the way absolute values work, right? And this side's negative, so there's no solution. There's no solution, and again, the reason there's no solution is that this is either a positive or a 0, and that can't equal a negative, right? That's not possible. And I don't know why they both accidentally ended up being negative 2s. It's just a coincidence. If you had solved, you would have gotten answers. Now, one way to do this, if you're like, hey, I just really, really hate this, or if you're not sure, if you get something and you're like, I think it's no solution, but I'm not sure if I'm crazy, you could put the entire left-hand side in your calculator as y1, and you could put the right-hand side in as y2, right? And that would be absolutely fine. So I'm going to go ahead and walk you through doing that, and we're going to see what happens. One word of caution I'll give you is that your y2 here is an 11, which is higher than the typical window you're going to see. So if I just show you what this looks like when we put this in your calculator, we know that it should be no solution, but I'm going to go ahead and put it in my calculator. When I type it in my calculator, my y1 would be negative 2 abs, parentheses, x minus 3 plus a 7. And my y1, so that's my y1, my y2 would be an 11. Notice that this is above a zoom 6 window, because the zoom 6 window only goes up to 10, so you're going to have to press window and extend your window so that you can see that there's no point of intersection. So you're going to have to press window, and you're going to have to raise your y max. Sorry, that's not how you spell raise. You're going to have to raise your y max to something like, I'd probably pick 15, like so that you can definitely see 11. So if we go ahead and put this in my calculator, right, so I'm going to go to my y equals. I'm going to type in negative 2. Remember, using the negative button, not the minus. The negative button is right here, right? So negative 2, math over to number, abs, and then I'm picking x minus 3 plus a 7. It is important that you close this parenthesis because the 7 is not inside the absolute value. And then I'm going to pick an 11. Since I know that 11 is going to be too high in my window, I'm going to go to window, right? There's a button for window, and I'm going to go to y max, and I'm going to make it a 15. That'll make me able to see that 11. And now when I graph it, what you're going to find is you're going to see a graph that doesn't intersect. You'll see the absolute value, which looks like a V, and you'll see the line, and they don't intersect, right? So if I were to graph this, and notice that this went up to like a 15 here, so it was more like this. One of them looks like this, and one of them looks like this, and they just don't intersect. Which, the intersection, right, the place where they do this, those would be my solutions, and these just clearly don't intersect. So that's why there's no solution. So you can definitely check that on a calculator. I'll also point out, and we're going to do one more equation example, that there are examples where equations are fairly difficult, and it's much easier to graph them than it is to do something by hand. So we're going to do one. We're going to do one that's in the book as example 2, but we're going to call it our example 5. And we're going to walk through how you could do it either by hand or with a calculator, but it's a little bit tricky. So we're going to do example 5, which is actually example 2 on page 64 of your book, okay? We're going to solve x minus 3 equals 3x plus 5. Sorry, x minus 3 in the absolute value equals 3x minus 5, not in an absolute value. Now, this is tricky because this is that locked box, right? This is that locked box. So if you were going to do this, there's 2 ways to do this, okay? Option 1, which is not at all a bad option, is to say, you know what, just forget this, man. I'm not going to deal with this. I'm going to make my left-hand side my y1. I'm going to make my right-hand side my y2, and I'm going to do second calc intersect. And that's not wrong, okay? That's absolutely fine, all right? So if you chose to do that, your y1 would look like this, abs of the quantity x minus 3. Your y2 would look like a 3x plus 5. And then we're going to go ahead and walk through what that graph looks like, and we'll find those answers. So I'm going to go ahead and type exactly what I wrote there. So I'm going to type in my abs, math, number, I pick abs, and then I type in x minus 3. right? And I'm going to type in 3x plus 5, so just to show you that's what that should look like, right? Now, I'm not currently zoomed standard because I changed my window in the last problem. Sorry, the light was shining on the thing. Changed my window in the last problem, so I'm going to go ahead and zoom 6 and see what happens, right? When I zoom 6, there's my one graph, there's my other graph, and sure enough, they do run into each other. They run into each other right here, right? So, what seems to happen, right? So if I then, so I get a graph that looks kind of like, and this is really the level of commitment I need to your graphs if you're sketching something that you put in a calculator. It looks like this one looks kind of like this. Hey, look, there's that point of intersection, right? Like, I don't need it to be the prettiest graph I've ever seen. And then you're going to do second calc intersect, right? So you're going to do second calc intersect. So second calc, you go down to 5, which is intersect. You scroll to where you think they're hitting each other, right? As close as you can to where they hit, and enter, enter, enter. And I'm going to get that x is negative 0.5. So that's my answer, right? And the y value is irrelevant because remember, there was no y in this problem. I wrote the y's to put them in my calculator, right? Okay, so it turns out that the only answer is x equals negative 0.5. Now we're gonna walk through how we can do that by hand, but option 1 was on a calculator. I'm going to argue that in a problem like this, where you have some x's in an absolute value and some x's not, the calculator is by far the easier option, okay? The other option is that we do it by hand, okay? So we're going to walk through this by hand because I want you to get the logic that it still works the same way it did when it was numbers, right? So if we do this by hand, 3x plus 5. The caveat here, right, the extra like ruler restriction when we do this by hand, is that you're going to want to check your answers because these problems tend to have what we call extraneous answers, meaning answers that seem to work when you solve but don't actually work when you plug in, okay? So if I think about this, I'm trapped with this lockbox. The stuff inside the lockbox could either equal the stuff on the right-hand side, right? So the positive case is that the stuff inside the box is the positive right-hand side, like exactly what the right-hand side was, boom, that's it, right? The negative case was that the stuff inside the box equals the opposite of the entire right-hand side, right? So the opposite of the right-hand side, which would be a negative in front of the whole binomial, the whole 3x plus 5. So I'm going to solve both of these. I'm going to move all my x's to the left-hand side, so subtract the 3x. I'm going to move the non-x's to the other side. So this is a negative 2x equals 8, and I'm going to get x is negative 4. And we'll talk about that in a sec because that was not an answer that we got when we did the other stuff. And in this case, if I distribute that negative, I get x minus 3 is negative 3x minus 5. I'm going to do the same thing. I'm going to move all my x's to one side, so I'll add the 3x's to the left-hand side. I'll add the 3 to the right-hand side. And I'm going to get 4x equals negative 2, which is x is negative 2/4 or negative 1/2, which is negative 0.5. Now, we already know this answer works, right? The trick here is if you choose to do this by hand, you should check your answers. So when you go back into check, right? When you go back into check, you're going to find that this answer fails, right? So you're going to get the absolute value of negative 4 minus 3 is a negative 7. So absolute value of negative 7 equals negative 12 plus 5. Well, that's a positive 7 equals a negative 7, which is a big fat lie. So this is not an answer. If I check negative 0.5, I'm going to get negative 0.5 minus 3 inside that absolute value equals negative 1.5 plus 5. So that's the absolute value of negative 3.5 equals 3.5. And sure enough, I get 3.5 equals 3.5, which works, which is why this is the only answer. Again, excuse me, it's not wrong to do it in either method, but be aware that if you do this by hand, you're probably going to have to check your work to make sure that there aren't extraneous answers. Again, just to give you what that word means, extraneous, so it looks like extra, and then neous. An extraneous answer is an answer that worked when we were solving things, because this did when I solved it worked, but it doesn't actually work in the problem, okay? So extraneous answer, and again, you have to check for those. They wouldn't show up in the calculator, but they do show up if you do them by hand.